Okay, so Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Farraas Al-Faruq. I'm from class MB-48-INT-GAB. My name is 1401224456. And today, for my final project, I will be presenting and teaching you guys about how to do and understand about matrix function. So what is a matrix function? Matrix function is basically a collection of elements arranged in rows and columns. So we can just imagine an analogy of this. Basically, imagine a table or a spreadsheet that are divided into columns and rows to help you summarize data and also calculate it. So in example, if you were to have a function like 2x plus 1 equals 5, that means we can just simply find that 1x is equal to 2, which means that 2 times 2 plus 1 is 5, just like the equation. But what if the equation is actually quite hard and complex, such as like it's having a 3-part and also 3-part down below again? So that is the main function of matrix actually, other than to group the data in a simple way. Okay, so let's hop into it. So here we have a matrix. This is a 2 by 2 matrix, or we can call it a square matrix. Basically, a square matrix is a symmetrical matrix that has the same number of columns and also row. So here is the row. Row is basically the part that goes to the right side. So in here, we can see that it is 1 and 2. And for column is the one who goes down below. So in here, we can see that it is 1 and 3. So I will explain to you about simple matrix operation. The first one is addition and subtraction. So imagine we have two matrices. The first one is A, B, C, D, and the second one is P, Q, R, S. So simply say, if we were to calculate it, we can just, let me write it here. So to add this, just basically add the first column and first row with the first column and first row from the B matrix. So we can do it like this. And then goes to the same as well with the other part. C plus R, and the last one is T plus S. It is quite simple. And for subtraction, it just goes the other way around. So like A minus P, B minus Q, C minus R, and D minus S. Okay, just add that. Okay, so next for multiplication, it's actually quite simple as well. So basically what you need to do is just like multiply the first row of A with first column of B. So we can just do it like this. I'm gonna go a bit here. A times B plus B times R. And also for the next one. And then for the next one, basically just the first row of A with the second column of B. So A times Q plus D times S. And then similar with this, so basically this the second row with the first column, which is C times P plus T times R. And for the last one, C times Q plus T times S. Sorry about that. And there we have it. So other than square matrix, as I explained it here, there's also other part, which is the identity matrix, which consists only of 1 and 0. And also a zero matrix, which the name summarizes it. It only includes 0 in its matrix. And then we have a determinant. So what is a determinant? Determinant is basically a signature number that are used in a matrix to solve a function or an equation. So on how to find it, we just basically multiply it diagonally and also subtract it on the other part. So for this matrix, we can just do, this is the determinant symbol, so we can just do A times D minus B times C. So here's the function. Okay, so now we can hop into the example question and try to solve the function. So this is a linear function question, which the question states and asks to determine x1, x2, and x3 if we have a function of 2x1 plus x2 plus x3 equals to 8, x1 plus 2x2 plus x3 equals to 7, and lastly, x1 plus x2 plus 2x3 equals to 9. So the first step we need to do is to actually convert it. The convert function is ax equals c. So a, we can find it here, the left number of the variable, the number of variable that we have. So if we were to put it here, we got 2x1, meaning it's 2. x2, that means it's only 1, so we have 1. x3, 1 as well. x1 to 1. To x2 is 2. x3 is 1. x1 is 1. x2 is 1. And to x3 is 2. And then we have to find the variable of x. Here we have 3x. Notice the repetitive pattern in here. There's x1, x2, and x3. So we just need to put it here, x1, x2, and x3. Oh, sorry, I forgot to put it there. And then the last one is coefficient. The coefficient is the result of the function. So we have 3 coefficients here, as it stated, 8, 7, and 9. So we'll put it here, 8, 7, and 9. So basically what we need to do to find the determinant, we need to put this matrix here and here. To find the determinant, which is I already explained here, but this is for the 2 by 2 matrix. So what do we need to do to find the determinant of 3 by 3 matrix? We can use a method which is called the Farraas method. So basically what is the Farraas method is? So basically we took two of the first 2 columns of the 3 by 3 matrix and add it into the right side. So we add it here, 2, 1, 1, and 1, 2, 1 here. So what is it used for? It is used for so you can do the equation without needing you to actually double think. So basically, first we have to calculate all the diagonals. There we have it. This is the positive diagonal, which means that it goes down from left to right. Without the Farraas method, we couldn't do this, do it a straight line. So it is a really great function and maybe essential if you want to find the determinant. And then we calculate the negatives. 1, 2, 1, 2, 1, 1, and 1, 1, 2. Because it's quite cramped here, I'll be going downward here and explain to you guys the equation. So for the positive diagonals, which goes down from left to right, we can get that. Wait, let me just put it here. Positive is 2 times 2 times 2, which is here. And then 1 times 1 times 1, which is here. And lastly, 1 times 1 times 1 as well. And easily done, you can just do the calculation by yourself. 8, 1, 1. And to sum it up, 8 plus 1 equals to 10. And then we find the negative diagonals, which go from right to left. So 1 times 2 times 1, as you can see here. And then 2 times 1 times 1. And lastly, 1 times 1 times 2, which to sum it up, first we need to calculate it actually. We get 2, 2, and lastly 2. And to sum it up, we add these 3 together and we get 6. So by calculating it like this, positive minus the negative diagonal, we found that the determinant is 4. Okay, next up, we need to find the minors. What is the minors? Minors is actually a function where we count by hiding the row and also the column. So let's say that, wait, let me put it all here first.
It is that something game that will be getting like get it. You bring it to usually the intent. Solution for that. And then that's what we think with it.
So let's say that the M11 means that first row and first column are hidden. So we can hide it like this to the first row and also the first column. So what we get here is this 2, which is 2, 1, 1, 2. So what we need to do next is actually multiply, similar to how we count the determinant. First we find the positive diagonal and also negative diagonal, and then we subtract it. Okay, so 2 times 2 is 4, minus 1 equals to 3. And then next up is M12. That means the first column and also the second row, which we get 1, 1, 1, 2. 1 times 2 is 2, minus 1 times 1 is 1. Then it's 1. The result is 1. And then M13, similar to before, M1, the first column, and also the third row, we get 1, 2, 1, 1. So 1 minus 2 equals minus 1. Again, 2 and 1. 1, 1, 1, 2. 2 minus 1 equals to 1. M22. Just here and here. So we got 2, 1, 2. 2, 1, 1, 2, sorry. So 4 minus 1, 3, M23, similar, 2, and then 3, we got 2, 1, 1, 1. So 2 minus 1, 2 minus 1 equals 1. And then M3, 1, 3 and 1, so we got 1, 1, 1, 2. This means 2 minus 1 equals 1. M3, 2, 2, 1, 1. We again 2 minus 1 equals 1. And M3, 3, it is 2, 2, 1, 1, 2. So 4 minus 1 equals to 3. Here we have it. Actually the first, the M31 is like this. So it's 1, 1, 1, 1, 2, 1. So actually the other way around, which is 1 minus 2, where we got minus 1. Okay, there we have it, the minors. 3, 1, minus 1, 1, 3, 1. minus 1, 1, and lastly 3. Next up, we gotta find the cofactors. So basically what the cofactors do is that if the row added with the column number is even, then the number will be equal. And if the number of column added with row is odd, that means that the result will be multiplied by a negative. So M11, which means M1 plus 1 is 2. So this is even, right? So the result is, okay, let's just do it like this. Plus,
Sorry.
the result is 3. So because this is even, we didn't do anything with it. Sorry, I should have done this. Okay, so the result is 3. And then next up, M1 plus 2. This is odd, right? Which is 3, the result. So we add negative here. Negative of this one is 1. So it is negative 1. And then lastly, M1 plus 3. 1 plus 3 is 4. So it is even, right? So we don't do anything. We keep it even also, which the result is negative 1. And then do it with the others as well. M2 plus 1 equals 3. So it's negative 1. M2 plus 2 is 4, which means it's even. We make it equal. We don't do anything to the number. We got 3. And then M2 plus 3, which is 5. It's odd, so add negative in front of it. And 1. We got negative 1. And then again, M3 plus 1. It's even, so keep it equal. Negative 1. M3 plus 2, which is 5, and it's odd, so add negative in front of it. 1, negative 1. And lastly, M3 plus 3, which is 6, it's equal. So the answer is even. We don't do anything with it. It's 3. Okay, so we have found the cofactors. And then after we found all of this, we try to make the adjoint matrix, which means that it will be transposed. So we put all of the result of cofactors here into a matrix. Adjoint. Which is here, 3 minus 1 minus 1. Wait, let me put it here. 3 minus 1 minus 1, minus 1, 3 minus 1. And lastly, minus 1 minus 1, 3. So to transpose it, we basically just need to swap the rows with columns. Yeah, it's actually the same. The other way around. So here, 3 minus 1 minus 1, we put it into the column. Minus 1, 3 minus 1, put it in the second column, and so. Here, 3 minus 1 minus 1, minus 1, 3 minus 1, lastly, minus 1 minus 1, and 3. Since we have the same result after it's getting transposed, that means we have a symmetrical matrix. And so it's fine. If it happens to be similar, we just go to the next. And so finally we go into the solving stage, which this is the function a power of negative 1. A power of negative 1 with c times c. So how do we get this determinant with power of negative 1? So we actually have the determinant already. We found it to be 4. So if we power it to minus 1, as it's easy, we get it as 1 per 4, or 1 divided by 4. Sorry. Which equals to c. Here we already have the c as well, 8, 7, and 9. And then we just put it into the function. Okay, we create a new matrix. 3. As you can see here, a power of minus 1, sorry. 3 per 4. I think we need to. Minus 1 per 4. Minus 1 per 4. Again, the same thing. 3 per 4. And 3 per 4, lastly. Multiplied by c. Times a, times 7, and lastly, this is times 9. Okay, so we just need to calculate the x1, x2, and x3. So basically what we need to do is to calculate each variable with this part here. 3 per 4 times a plus minus 1 per 4 times 7. And lastly, minus 1 per 4 times 9. Which will get us 24 per 4 plus minus 7 per 4 plus minus 9 per 4. And we can just add this and negative, 16. So we will get 8 per 4, which the result is 2. And then do it the same with the other parts, which is minus 1 per 4 times 8 plus 3 per 4 times 7. Lastly, minus 1 per 4 times 9.
That's it.
Which gets us this number, minus 8 per 4, 21 per 4, plus minus 9 per 4. Then we get this 4 per 4, which get us 1. And then for the last one is x3. Again, minus 1 per 4 times 8 plus minus 1 per 4 times 7 and 3 per 4 times 9. Which gets us this number, eight per 4 plus minus 7 per 4 plus 27 per 4. And we get this one. We got the result of 12 per 4, which is 3. And so we have found all the x. Here is the result. x1 is 2. x2 is 1. And x3 is 3. There you guys have it. But if you guys want a simpler method, we can just use a Kramer method, which includes substitution. where you guys have to substitute each column with C. So in example, if we have a x1 here, we just need to substitute the first column with C. So we get 8, 7, and 9. The rest staying the same. 1, 1, 2, 1, and lastly 1 and 2, where we have to find the next determinant. Again, 8, 7, 9, 1, 2, 8, 7, 9, 1, 2, 1.
Right.
Again, that's 1 times 1 times 9 plus 1 times 7 times 1 subtracted by 1 times 2 times 9 minus 8 times 1 times 1 minus lastly 1 times 2 times 7. Oops, 1 times 2. 1 times 7 times 2, 1 in. Equals to 8. Okay. And so we just need to calculate it. This A1 per which gets you 8 per 4, and you got 2. And then the same for A2, which the result is 4. And then so x2 is 4 per 4 equals 1. And for A3, the same, we got 12. x3 equals to 12 per 4, which gets us the similar number of 3. So x1 is 2, x2 is 1, and x3 is 3. So yeah, so basically, here is the Cramer's rules as an alternative of the function.